We're going to be looking at trig word problems today. So really, we're just taking SOHCAHTOA and using it to solve a real-world application problem. If you can do SOHCAHTOA and you know these two definitions at the top of the paper here, these are going to be no problem. So before we kind of look at some examples, there's two definitions, like I said. The first is an angle of elevation, and the second is an angle of depression. Now, an angle of elevation is an angle above a horizontal line. And then an angle of depression is the opposite of that. It's an angle below a horizontal line. And this little picture off to the right here gives you an example of that in real life. So you've got this little hiker man here, and there's two situations. He's either going to be looking up at the top of the mountain or down to this house down here. So let's look at the first scenario where he's looking up to the top of the mountain. What I just highlighted right there, where he's looking, that is called a line of sight. And it makes sense. I mean, where he's looking, line of sight. Now, there's two angles that are created there. And notice these dashed horizontal lines. They went away from his eyes and drew a dashed horizontal line. And where he's looking, the top of the mountain, they drew a dashed horizontal line there as well. That's the horizontal line that they're referring to in the definition over here. Okay, so this man looking up to the top of the mountain, angle 2 here, that's called an angle of elevation. It's above that dashed horizontal line. And it makes sense. He's looking up to the top of the mountain. If you elevate something, you kind of lift it up. So that makes sense there. Plug in my computer here, so sorry. Now, angle 1 there at the top is the same idea. Okay, and this angle is below this dashed horizontal line, so that's an angle of depression. Now, same idea if you look down, think like you're depressed, you're down, that's depression. Okay, we've got another case if the man looks down at the house here. Angle 3 is below that horizontal line, so that's a depression angle. And then angle 4 is above the horizontal line, so that's an elevation angle. Now, I want you to make a note down here. For a situation, an angle of elevation and depression are always congruent. The reason they're congruent is because horizontal lines are always parallel, so they're AIAs. Okay, so that's going to be real important. I'm going to highlight that. That's going to be necessary to solving some of these application problems here. Okay, so let's put this into play. The first two examples are not too terrible because they give you the picture already. So let's read the first one. It says, you see a rock climber on a cliff at a 32-degree angle of depression. Okay, so here's you. You're looking up at a rock climber here on a cliff. I'm a really good artist, as you can already tell. You look up, so that's an angle of elevation. They labeled it. The horizontal ground distance to the cliff is 1,000 feet. Find the line of sight distance. Remember, that's where you're looking. So that's going to be the hypotenuse of this triangle. You looking up at the climber. I'm going to call that X. They gave me the picture, so all I have to do is figure out, am I going to use sine, cosine, or tangent? So remember your SOHCAHTOA. Now I've got the adjacent leg and the hypotenuse that I'm trying to find. So adjacent hypotenuse, that's cosine of my angle, equals the adjacent leg, 1,000, over the hypotenuse x. I'm hoping that you guys have practiced SOHCAHTOA enough that you know when the number's on top. When you cross multiply and work it out, you end up dividing. So that's how I punch it into my calculator. They didn't tell me how to round, so I'm going to say it's about 1,179 feet. Okay, example 2 here. An airplane flying 3,500 feet above the ground begins a 2-degree descent. So that's an angle of depression. How many miles from the airport is the airplane when it starts its descent? Now, they already told me what I'm trying to find, X right there. You guys, these problems, you need to use SOHCAHTOA. So you have to have a right triangle. You have to find that right triangle. So I could use this one right here. Here's my 90. There's my angle 2. I want to find X, which is the hypotenuse, and you have the opposite leg this time with the 3,500. So opposite and hypotenuse is going to be sine of 2 equals 3,500 over X. Okay, same idea. When you plug this into the calculator, the number's on top, so you divide. And I get a really big number, 100,000, about 288 feet. If they don't tell you how to round, you can round however you want. Okay, on the back, this is where it gets real here, where we have to draw the entire picture ourselves. So, example 3 says, an airplane pilot sees a life raft at 26 degrees angle of depression. Okay, I am a terrible artist here, you will see. My airplane kind of looks like a fly, but that's okay. There's my airplane. Let's hope yours is better. That's the pilot in there. So, okay, we're flying over the ocean, obviously, because we spot a little life raft. That's a life raft, not a donut. Now, we know also that the airplane's altitude is 3 kilometers. What's this airplane's surface distance, d, from the raft? Now, here's what I need to do. I need to make a triangle out of this whole thing. So, I know that the pilot's going to be looking down at the raft. That's my line of sight distance. I would draw that for sure. The airplane's altitude, so that's how high it is 3 kilometers. Complete my triangle here. I want to find the surface distance, so on the ground or on the water, so I'm going to call that D. The place where people mess up is when they put in the angle of depression. People put it up here at the top of the triangle, but remember that the definition says it's below a horizontal line. You should draw the horizontal line so you do not mess this up. If you go from the pilot, the person who's doing the looking here, and draw that dashed horizontal line away from his eyes, below that horizontal line, that's the angle of depression, 26 degrees. Now, remember I told you that an angle of elevation and angle of depression are always the same. So if you were on the life raft looking up, that angle would also be 26 degrees. And that's the angle you want because that's inside the triangle. Okay, number one place people mess up every year, they put the 26 up there, but it actually needs to come down here for the angle of elevation. Okay, now use your SOHCAHTOA. So I have the opposite and the adjacent leg, so that's tangent. So that's how I would set it up. The number's on top again, so I'm going to do 3 divided by tan 26. And I get about 6.2 kilometers. All right, last example. A surveyor stands 200 feet from a building. So I'm going to draw the picture as I read it this time. There's my surveyor. Standing 200 feet from a building. And let's see, he's measuring the height of the building with a 5-foot tall theodolite. Okay, I don't know if you guys have ever seen those men like on the side of the road with their hard hats surveying the land, and they use this little tripod instrument. That is called a theodolite. And it's 5 feet tall. Okay, and this little theodolite measures the angle of elevation to the top of the building at 35 degrees. I want to figure out how tall the building is. Okay, so I'm going to draw the line of sight distance. This little theodolite is looking to the top of the building. I need to draw that horizontal line away from what's doing the looking here. Above that horizontal line is an angle of elevation of 35 degrees. I want to figure out how tall the building is, so I'm going to call this X. Okay, here's my right triangle, so I'm going to bring up this 200 feet here, and I'm just looking at this triangle right here. So I see the opposite leg and the adjacent leg, which is tangent. Okay, this time the number is on the bottom, so I would multiply by 200 on both sides to solve for X. And I get about 140 feet. Now, think closely here. They're not going to give you a number in these problems for you not to use it. I haven't used this 5 feet for the theodolite at all yet. I have from here to here is 140, but I want the entire height of the building. I want all of this. I only know that. So this right here is 5 feet. That's how tall that instrument was. So you actually need to add that on and tell me the whole height of the building is 145 feet.